Don't forget to subscribe to our channel for more videos, and press the bell icon to receive updates.
Hello friends, in last video we have studied the concept of elasticity, plasticity and rigidity. In this video we shall study the concept of stress, strain and modulus of elasticity, and particularly in this video we are concentrating on longitudinal stress, longitudinal strain and Young's modulus of elasticity. The property by virtue of which material bodies regain their original dimensions, size, shape or both after removal of deforming force is called elasticity. The material exhibiting elasticity is called elastic material and the body is called elastic body. Example, rubber, steel, aluminum, copper, etc. When the body is stretched, the interatomic spacing increases, and when it is compressed, the interatomic spacing decreases. In both cases, internal forces are created in the body which tend to restore the atoms back to their original positions. Such internal forces are called internal elastic forces or restoring forces. The magnitude of restoring or internal elastic force is the same as that of applied force. These restoring forces are responsible for the elastic property of the body. Now let us understand what is meant by stress. The net internal elastic force, that is restoring force, acting per unit area of the surface which is subjected to deformation is called stress. Mathematically, stress is equal to restoring force divided by area, or that is equal to F by A. Stress is denoted by letter sigma. SI unit of stress is Newton per square meter or Pascal, and its dimensions are L minus 1, M1, T minus 2. Units and dimensions of stress are the same as that of pressure. Both the pressure and the stress have the same dimensions, that is L minus 1, M1, T minus 2. But the pressure is a scalar quantity while stress is a tensor quantity. Hence, they are two different physical quantities. Now let us study the characteristics of stress. Stress is internal restoring force per unit area. It opposes the change in the size, shape or both of the body. That is, opposes deformation. It is a tensor quantity. Tensor is a physical quantity which is neither scalar nor vector. They don't have a definite direction. They may have different values in different directions. These quantities have magnitude and directions, but they do not obey the rules of vector addition. Other examples of tensor quantities are moment of inertia, surface tension, electric current, etc. Its SI unit is Newton per square meter. Its dimensions are L minus 1, M1, T minus 2. Now let us study the meaning of the term strain. The change in dimensions per unit original dimensions of body subjected to deforming forces is called strain. Mathematically, strain is equal to change in dimension divided by original dimension. A strain is denoted by letter E. It is a pure ratio, that is ratio of two similar quantities. Hence, it is unitless, dimensionless quantity, or we can say its dimensions are L0, M0, T0. Now let us study the characteristics of strain. The strain is defined as the ratio of change in dimensions of body to its original dimensions when subjected to deformation. For longitudinal loading, both the longitudinal and lateral strain are produced. This concept will be discussed in concept of Poisson's ratio. It is a scalar quantity. As it is ratio of two similar quantities, it is a pure ratio. Hence, it is unitless, dimensionless quantity. Now, let us study Hooke's law of elasticity. Within the elastic limit, the stress developed in the body is directly proportional to the strain produced in the body. Thus, by Hooke's law, stress proportional to strain. Therefore, stress is equal to constant into strain. Therefore, stress upon strain is equal to constant. This constant of proportionality is called the modulus of elasticity or coefficient of elasticity. Unit of stress is Newton per square meter and strain is unitless. Hence, SI unit of modulus of elasticity is Newton per square meter or Pascal, and dimensions are L minus 1, M1, T minus 2. Its units and dimensions are same as that of a stress. A graph is drawn by taking stress on y-axis and strain on the x-axis. We get a straight line passing through the origin up to elastic limit. The slope of this line gives the value of the modulus of elasticity. Now let us understand the meaning of the term elastic limit using the Hooke's law. Elastic limit is the upper limit of deforming force up to which the deforming force is removed. The body regains its original shape and size completely. If the deforming force is increased beyond this limit, there is permanent deformation in the body called permanent state. Elastic limit is the property of a body, while elasticity is the property of the material of the body. Elastic limit differs widely for different materials. It is very high for substance like steel and low for the substance like lead. Now let us study characteristics of modulus of elasticity. The ratio of the stress produced in the body to corresponding stress produced in it is called the modulus of elasticity of the material of the body. It is the characteristic property of the material of the body. It is different for different materials. Its SI unit is Newton per square meter and its dimensions are L minus 1, M1, T minus 2. With the rise in temperature, values of moduli of elasticity decreases. Depending upon the loading, there are three types of elasticity constant. If there is a change in length of a body, then the corresponding elastic constant is called Young's modulus of elasticity. If there is a change in the volume of the body, then the corresponding elastic constant is called bulk modulus of elasticity. If there is a change in the shape of a body, then the corresponding elastic constant is called modulus of rigidity. Solids have all the three moduli of elasticity. Liquids and gases have only bulk modulus of elasticity. Liquid and gases cannot be deformed along one dimension only and also cannot undergo shear. Hence, they don't have Young's modulus and modulus of rigidity. Now, let us study longitudinal loading in detail. When we say longitudinal loading, means it is stress along the length. Now, let us understand the first term, longitudinal stress. When the deforming forces are such that there is a change in the length of the body, then the stress produced in the body is called longitudinal stress. Thus, longitudinal stress is equal to force F divided by area A. You can see the diagram on the right hand side. It is a rod of cross-sectional area A subjected to tensile force F. The original length of the wire rod was L and the extension in the rod is small l. Then longitudinal stress is equal to F upon A. If the deforming force is applied normal to the surface of a body, then the applied force per unit area is called normal stress. Normal stress is of two types, viz. Tensile stress and compressive stress. Now, what is tensile stress? When the deforming force is such that there is an increase in the length of the body, then the stress produced in the body is called tensile stress. Compressive stress. When the deforming force is such that there is a decrease in the length of the body, the stress produced in the body is called compressive strain. Now let us study the concept of longitudinal strain. When the deforming forces are such that there is a change in the length of the body, then the strain produced in the body is called longitudinal strain. The longitudinal strain is further classified into two types, tensile strain and compressive strain. Mathematically, longitudinal strain is equal to change in length small l divided by original length capital L. The longitudinal strain has no unit and no dimensions. Now let us study the tensile strain. When the deforming force is such that there is an increase in the length of the body, then the strain produced in the body is called tensile strain. And when the deforming force is such that there is a decrease in the length of the body, then the strain produced in the body is called compressive strain. Now let us study about Young's modulus of elasticity. Within the elastic limit, the ratio of longitudinal stress to corresponding longitudinal strain in the body is always constant, which is called Young's modulus of elasticity. It is denoted by letter capital Y or capital E. Young's modulus of elasticity is not defined for liquids and gases. Its SI unit is same as that of a stress, that is Newton per square meter or Pascal. Its dimensions are L minus 1, M1, T minus 2. Mathematically, Young's modulus of elasticity is equal to longitudinal stress divided by longitudinal strain. Now let us derive an expression for Young's modulus of elasticity of the material of a wire. On left hand side, you can see a small diagram. A wire of length capital L and radius of cross section small r is fixed at one end and stretched by suspending a load mg at the free end. Let small l be the extension produced in the wire when it is fully stretched. Now we have already studied longitudinal stress is equal to applied force upon area of cross section. So longitudinal stress is equal to F upon A. But here you can see that we have applied load mg. So F is equal to mg and area of cross section is pi r square, where r is the radius of the cross section of the wire. Now we already studied the definition of longitudinal strain. Longitudinal strain is equal to change in length upon original length, that is small l upon capital L. Okay. And Young's modulus is defined as longitudinal stress upon longitudinal strain. Now substitute the values of above equations. It is mg upon pi r square divided by small l upon capital L. Rearrange the terms. I will get y is equal to mg capital L divided by pi r square small l, where m is the mass of the load attached, small g is acceleration due to gravity, capital L is the original length of the wire, small r is the radius of cross section of wire, and small l is the extension in the wire due to loading. Now let us study characteristics of Young's modulus of elasticity. Within the elastic limit, it is the ratio of longitudinal stress to longitudinal strain. It is characteristic property of the material. It is associated with the change in the length of the body. It exists in solid material bodies. It is a measure of stiffness of a solid material. Young's modulus of the material of wire is given by y is equal to mg capital L upon pi r square small l. Now let us study one of the important concept of elasticity, that is Poisson's ratio. The concept of this constant was introduced by physicist Simon Poisson. When a rod or a wire is subjected to tensile stress, its length increases in the direction of the stress. To keep volume constant, its transverse dimensions decrease and vice versa. That is, when the length increases, the thickness decreases and vice versa. In other words, we can say that the longitudinal strain is always accompanied by a transverse or lateral strain. The ratio of transverse or lateral strain to the corresponding longitudinal strain is called Poisson's ratio. It is denoted by letter m. It has no unit. It is a dimensionless quantity. Poisson's ratio is equal to lateral strain divided by longitudinal strain. For homogeneous isotropic medium, -1 less than equal to small m less than equal to 0.5. In actual practice, Poisson's ratio is always positive. There are some materials with a negative Poisson's ratio. Poisson's ratio of cork is 0, that of metal is 0.3, and that of rubber is 0.5. Materials with the negative value of Poisson's ratio are said to be auxetic. They grow larger in the transverse direction when stretched and smaller when compressed. Most auxetic materials are polymers with a crumpled foamy structure. Pulling the foam causes the crumples to unfold and the whole network expands in the transverse direction. Thank you for watching this video. In the next video, we shall study to solve problems based on longitudinal stress, longitudinal strain, and Young's modulus of elasticity.
Don't forget to subscribe to our channel for more videos, and press the bell icon to receive updates.